Hello. So today we will be looking at the second part of the questions that we've designed in week 4. So it will be on design patterns, the questions. So we will look at sample questions that are written with the answers, and we will discuss them. So let's start. So question on general aspects of design patterns. So as you know, design patterns are the way we implement the design principles so that we will have structured code. So what is the general idea of a design pattern in software development? So you can have such questions in your exam. How do you approach the way to answer it? I mean, so in general, so it is a general pattern for putting code together, giving particular name. So you need to give it a name that suits it. We have many names, so we will see more of it. It must be applicable in a variety of situations, but used to solve a particular sort of problem. So design patterns are a way of passing on expertise in programming. They represent solutions experts have found they are often using. So what this means is that design patterns are created by programmers that have worked for many years, 15, 20, 30 years in the industry. And they found new ways of going around solving problems. So they've decided to put it down and give them names so that people can use them. People who don't have experience, novice programmers, can use them, because these design patterns, the knowledge was created based on experience, long time experience actually. So they provide a vocabulary which helps developers communicate ideas about program structure. So you need a vocabulary, that is, you need a term, a word to describe something without which you may not be able to convey the message to your audience or to your student. So you will need to create a name, say adapter design pattern, or whatever you will call it. So even in design principles, you have names, adapter design principles or object-oriented programming method. So you have a name to describe it. Without a name, you may not be able to speak about it. So, question on factory objects. So let's look at them. Explain the factory object design pattern and how its use fits in with the concept of separation. So as we know, factory, what is a factory in English word? In a factory, you manufacture things, you create objects, it's the same thing. In factory design pattern, it's about creating objects, but of course in this case, not objects like cars or bicycles or manufacturing things to it, but creating software artifacts and objects. So a factory object is an object on which factory methods can be called. And let's see, what is a factory method? So a factory method is a method that performs like a constructor. So we know a constructor, of course, in programming. So a constructor, of course, is it's like a method with what? The same name as the class, and it returns the type of the class. So a call to it creates and returns new objects, but it is a standard method called in syntax. So what we mean is that it performs like a constructor. So a call to it will create and return a new object, but it is a standard method called in syntax. So what does that mean? You will see that when it is returning, it will say return new class. You will call, they put the name of that class, and it could be the what? The superclass or the what? The subclass of it. A constructor can only return an object of its actual type. That is the type that what? Created it. The actual type, as we said yesterday. But a factory method could return an object whose actual type is subtype of its return type. So it means that we can have a class which extends another class, and then when you create a factory class of its superclass, you can now return it as the subclass type. But in constructor, it has to return its actual type. That is one difference between it and a constructor, that a factory method. And that tells you that a factory method will return an object, actually. The actual type of the object returned by a factory method could be determined by its arguments and other runtime factories or factors. This helps establish separation, since it means the object returned by the factory method is known to meet the specification of its return type, but there is not the closer connection of the calling code being dependent on its exact class. So it's not dependent on its exact or actual class. You can return the subtype of it, which makes it flexible, that you can actually return other types. Of course, they will be related, but maybe not closely related in a way. A factory method may be used to hide the actual type of the object it returns from the code which uses it, so it is viewed only in terms of a super type. So you can see that, which means you can hide the return type, unlike a constructor, which you have to return its actual type. You can actually hide it and return its subtype or its super type. Now another question. Explain the factory object design pattern and how its use fits in with the concept of separation. Of course, it's the same question, but we're still explaining it. With the use of a factory method, there is the additional separation of aspects of the new object being defined by the factory object and not by the calling code. So by this, it means that you can use a factory method and have an additional separation of aspects of the new object that you have defined by the factory object and not by the what? The calling code. So generalized code may be written because you can use it to return subtype or supertype and hide it, so it can be general, which means it's not restricted to the return type as we have in constructors. With aspects of object construction parameterized, meaning a factory object is passed to a code through a parameter, which means you can pass a factory object as a parameter, and you can make it general because it inherits from other classes. New objects used in the code are provided by calls of factory methods on these factory objects. The behavior of a generalized code can be varied by passing different objects to it, so enabling that the code to be reused in different ways, because you can see that, which means inheritance has been put into parameters that can pass to a method by creating factory classes and objects, and the methods. So it means that you can actually generalize your parameters so that you can pass different types of parameters to it as objects. Some aspects of the objects generated by code of a factory method on a factory object may come from data stored in the factory object rather than from the object which made the factory methods. So you can see that you have given it a variety of ways to actually pass parameters. In some cases, a factory method may return a reference to an existing object rather than construct a new object. Like we said, so a reference, if you have aliases which reference to one another, so it means that you can even put it because you can create variables of the constructor of the factory class itself, and the method itself, so you can pass it as reference. For example, in the singleton design pattern or the object pool design pattern, so you can do that. So in the singleton, we know as the name singleton 1, and then for the design pool, many of them. Question on the decorator and adapter design patterns. Another question. Give a full explanation of the decorator design pattern and explain how it differs from the adapter design pattern. So let's see how we will answer this. This is how to go about it. The decorator, first, tell us what is the decorator and tell us what is the adapter before we can go to the differences. So the decorator design pattern is used in situations where we want to decorate code by giving it some extra behavior. What is decoration? Let's look at the term in terms of English language. If you want to decorate your house, what does it mean? It means you already have something, but you want to make it more beautiful, or you want it to have more functions, more functionality, more beauty by adding more things to it. It could be functionality, it could be some sort of painting or whatever. It's the same way. So it has to do with inheritance, actually. So if you inherit a class, say inherit from an interface or a class, especially interface, the methods, they have no code at all. So if you inherit it, actually you need to add something for it to actually do the work. You are decorating it. The idea is that the code we wish to decorate is contained in a class which implements a particular interface, just like I have said. So we want to decorate it. The decorator design pattern means having another class which implements the same interface, describing the outer or wrapper object. So which means the outer is the one that inherits it. This class has a field of that interface type used to refer to the inner or wrap object. So the class has a field of that interface. So that interface is wrapped is the one that is wrapped. Okay, so you remember we say a wrapper. So if you want to give a gift or present to somebody, you kind of wrap it in a beautiful paper. So inside it there is the gift, the actual gift, but outside it there is the wrapper, a piece of beautiful paper or whatever, shiny. That is how you will look at it. So the class that implements the interface is the wrapper. That is the beautiful cover that you have outside. Then the real or the actual present inside it, which is wrapped, is your what? Your interface is inside, while the class is outside. Each method in the interface is implemented in the wrapper class by a method which calls the same method with the same argument on the inner object. So each method in the interface is implemented in the wrapper class, which is outside, which is the outside part. Inside it, those methods are implemented by the method which calls same method with the same argument on the inner class, on the inner object, which is the interface in this case. But it will also perform some additional tasks. That is the decoration. Because, as you know, interfaces, their methods do not have implementation code. They will not do, in fact, on their own, they are useless in a way, until they cannot perform any action. They are just templates. Until you go ahead and implement the code that does the action on the method, then they can do something. That is the decoration that we're talking about. So the wrapper object may be used in any place where the wrap object was used, so long as that place refers to it through some variables of the interface type. The code will then perform as if the wrap object, which is what? The methods in the what? In the interface object was used directly, as exactly the same method calls are made with the principle of dynamic binding, and also do the extra work. We have discussed dynamic binding in our part 1 lectures. So we continue. Let's look at what is an adapter. We've seen a decorator. Let's look at the word adapter, or to adapt in English. What does it mean? It means that if you, for example, used to live in a very hot environment, and you have to go out and travel to another country that it is very cold, you will have to adapt to that condition so that you can live comfortably in that cold environment, because you are used to hot environment. It is a bit similar, so we're going to look at it. The adapter design pattern also has an inner and outer object and an associated interface, just as the what? The decorator. As we saw, the outer is the class, the inner is the interface that has been implemented by the class. So let's look at it. But only the wrapper class implements the interface. So you can see the inner object is of a class that does not implement the interface. So in this case of an adapter, the inner object will be a class that did not implement that interface. Unlike in the decorator, it is a class that implements the interface. The methods of, so it has to adapt to it, because it did not, like I said, in the other condition, you are coming from a hot to a cold environment. So this one, the inner object does not have that interface that the outer object has. They are not the same. So it has to adapt to it. The methods of the interface are implemented by code, which calls what methods or combination of methods in the inner object is judged by the equivalent of the method of the interface in terms of its general specification, the equivalence, not the real one, unlike like we have in the decorator design pattern. The adapter design pattern is used when we have a class of objects which has already been developed, and we want to be able to adapt objects of that class so they can be passed to code and used as if they were of the interface type, but they were not. But we need to adapt them. Like I said, they are coming to a different environment. They've been developed already. When they were developed, they were not developed with that interface in mind. But now we want to bring them because we want some functionalities in them. And so we need them to adapt to our own interface. Question on the state design pattern. So here is the question. Explain what is meant by the state design pattern. State under what circumstances it is used. Give the benefit that using it provides to a software system. So let's go and see how we will if you find this question, remember these are past exam questions. The state design pattern involves an object that has within it a reference to another object that implements that same interface. What does it mean? You have a class, okay, that implements and so it has the state design pattern. So which involves an object that has within it a reference to another object that implements the same interface. So that object is produced from a class that has implemented the interface, and then the interface will now just, so like I was saying, so the state, a method called on the outer object will be implemented by the same method called being met on the inner object. With the state design pattern, under some circumstances, when a call to one of the methods in the interface is made, the inner object will be replaced by another object of a different class that implements the same interface. So now, when you call that object which did not implement the interface, for it to adapt, for it to come in, it will what? It will call the object of that what? That object that implements that same interface. This is used in cases where an object starts off best implemented in one form, but changes made to it by methods called on it may make it better implemented in another form. So it will change its state. So the basic idea of the state design pattern is to enable there to be a single object whose internal representation can change. That is why it's called state, from one state to another, with the change managed inside the class of the object. So instead of you manage it inside the class of the object. So let's continue. An example is an object representing a set of integers which could be implemented by an array of booleans or an array of integers, whichever way. So the representation by an array of boolean or booleans is suitable when the range of integers in the set is the set is small, but unsuitable if the range of integer is large. So in that case, you need to try to do it in a different way. So the state design pattern could be used where an object representing a set of integers has inside it a reference to an object representing a set of integers. Initially, the inside object would be one using an array, for example, of booleans as its implementation. But if numbers outside a particular range were added to the set, because it's an array, you remember an array will have a fixed range, say 100 objects that it can, so it cannot take, so if suppose it will take numbers outside a particular range, outside 100 for example, were added to the set, it will replace it by an object using an array of integers to represent the set. So which means that if it's boolean, which is true or false or whatever, then if it's not either way, you can take the range of integers to do it, or the other way, if it's integers, you can take boolean. The new inside object would be given the elements of the old inside object, which could be either boolean or integer, as the case may be. Code making use of the outside object could just use it as a set of integers without having any extra code to change it from one representation to the other when that is a good thing to do. In this way, it meets the dependency inversion principle, as it means the code using the set of integers does not have any dependence on the different versions of code that could implement it, because it can change from boolean to integers or integers to the boolean itself. And I think that is all about this lecture. So thank you for listening, and I hope you enjoy it. Thank you so much, and bye.